Hello and welcome. Today we are here to talk about the antibiotic apocalypse, a dangerous occurrence that isn't understood well enough. With troubling predictions by the World Health Organization, like 10 million annual deaths by 2050, let's learn more about antimicrobial resistance and what we can do to prevent it. Infectious diseases have always been a major cause of death among people. Even today, they account for 2 out of the top 5 causes of death globally and 6 of the top 10 in developing nations. The introduction of antibiotics into clinical use was arguably the greatest medical breakthrough of the 20th century. In addition to treating infectious diseases caused by bacteria, the power of antibiotics to prevent infection made many modern medical procedures possible, including cancer treatment, organ transplants, and open heart surgery. In just over 100 years since their discovery, antibiotics have dramatically changed modern medicine and extended the average human lifespan by an estimated 23 years. They are the most widely used class of drugs in medicine and the most familiar by name to the general public. However, misuse of these valuable compounds has resulted in making these drugs less effective in recent decades, making infections harder to treat. This is the phenomenon of antimicrobial resistance, or AMR. Is the greatest medical breakthrough of the 20th century really endangered today? This training is divided into 4 modules. The first module provides an introduction to antibiotics. The second explains the phenomenon of AMR and the causes behind its rise and growth. The third looks into the current situation in India and the US. And lastly, the 4th module speaks about how we can resist AMR. Before we learn about antibiotics and AMR, it is important to know the different types of pathogens that can cause illnesses. Knowing this difference is important to understanding one of the drivers of the growth of AMR. Pathogens fall into 4 broad categories. The first category are bacteria. These are single-celled organisms that can live and reproduce independently. There are both good and bad bacteria. In fact, good bacteria in our intestines play a critical role in our digestive system. Harmful bacteria cause illnesses such as pneumonia, tuberculosis, cholera, typhoid, etc., and they spread via water, air, food, and vectors such as mosquitoes and fleas. The second category are viruses, most famously the recent COVID-19 virus. These are actually just a piece of DNA enclosed by protein and are not capable of reproducing independently. They depend on a host to reproduce, though they can survive on outside surfaces and spread when people come into contact with these surfaces. The third category are fungi, multicellular organisms that are neither plants nor animals. Examples of pathogenic fungi include dermatophytes and candida. Fungi spread by direct contact or through contaminated articles and cause infections such as jock's itch and athlete's foot. The last category are protozoa, a type of parasitic organism that consumes other microorganisms or organic matter like soil and dirt. Protozoa can cause illnesses such as malaria and giardia. It is important to be aware of these 4 categories of pathogens because although all of them cause illnesses, antibiotics are only effective against bacteria. In other words, antibiotics are drugs used to treat bacterial infections and should be used against bacterial infections only. Resistance is prevalent across all antimicrobial drugs, such as antifungals, antivirals, antiparasitics, and antibiotics. But in these modules, we will only be covering bacteria and antibiotics. There are 4 categories of antibiotics as well, based on the source from which they are derived. First and largest category are antibiotics derived from a type of bacteria called actinomycete bacteria. The second comes from other kinds of bacteria. The third category, including the famous penicillin, comes from fungi. These three categories are naturally occurring antibiotics. The last category are those that have been chemically synthesized in a lab. The very first antibiotic, salvarsan, was actually chemically synthesized in a lab in 1910. However, antibiotics truly became famous and widespread following the discovery of the naturally occurring penicillin by Alexander Fleming in 1928. The period between 1940 and 1965 is generally considered to be the golden age of antibiotics. Most antibiotics in use today were discovered during this period. Since 1970, the discovery of new antibiotics has slowed down and AMR has grown in prevalence. In 2016, the UN declared AMR to be a fundamental threat to health. So what exactly is antimicrobial resistance, or AMR? Simply put, AMR is when antibiotics lose their effectiveness in killing bacteria. It arises from the misuse of antibiotics, as a result of which not all bacteria inside a patient are killed. The surviving bacteria develop resistance to the antibiotic, and the antibiotic in question becomes less effective or even completely ineffective against the same bacteria when the infection occurs again. This could make recovery from normal illnesses like respiratory infections or diarrhea much more difficult. With the golden age of antibiotics well behind us, it is very expensive and time-consuming to develop new antibiotics. The growth of AMR will thus result in an increase in the number and severity of illnesses and ultimately more deaths. A study commissioned by the World Health Organization predicted that without urgent action to control AMR, we could see up to 24 million people pushed into poverty annually by 2030 and 10 million deaths per year by 2050 from drug-resistant infections. Given this dramatic conclusion, it is very important for everyone to understand antibiotic misuse. Misuse of antibiotics can occur in three different ways. The first is overuse of antibiotics. This may be caused by excessive use of antibiotics, using more powerful antibiotics than required, or using broad-spectrum antibiotics when a more infection-specific drug is adequate. The second is misuse of antibiotics, such as when they are prescribed to treat viral infections, or when they are prescribed before tests are conducted to determine the nature of the infection. The third category is misuse by the patient. People often self-medicate based on their own knowledge of antibiotics and assessment of the infection, which often ends up being wrong. Patients also fail to complete the full course prescribed by the doctor, stopping midway when they start to feel better. Doing this will allow some of the bacteria to survive, thereby helping the bacteria develop resistance to the antibiotic. Lastly, AMR may also be spread through the mechanism of transmission. Veterinary misuse may cause AMR in cattle and eventually spread to humans through food, animal waste, or contaminated matter. AMR develops and spreads as a consequence of a combination of the above causes. The most dangerous outcome is the formation of superbugs, which are bacteria that develop resistance to not just one but multiple antibiotics. These are the most dangerous and can often be fatal. So let us look at how bad the AMR problem is. We will discuss it with respect to two large countries, India and the US. AMR contributed to nearly 5 million deaths globally in 2019, of which 1.3 million were directly caused by it. Today, AMR is prevalent in all countries around the world, regardless of income levels, and has been declared a top 10 global health threat by the World Health Organization. In the United States, nearly 3 million people are infected by resistant strains of bacteria each year, resulting in about 35,000 deaths. Several wrong practices are observed even in a developed nation like the US. People self-medicate on antibiotics, And those without access to medical insurance often try to save money by taking half a pill or doubling the interval between pills, which significantly increases the likelihood of AMR. Further, almost 28% of prescriptions are estimated to be unnecessary. In India, there were 3 lakh AMR-related deaths in 2019, including 60,000 neonatal deaths of newborn children. It is estimated that most traditional antibiotics have declined in efficacy by about 15%. And all drivers of AMR discussed in Module 2 are found in India, including the use of antibiotics without prescriptions and the widespread use of broad-spectrum antibiotics. Half of all interactions between patients and the healthcare system is estimated to lead to overprescription of antibiotics. Finally, AMR is more prevalent in low-income countries and is generally worsened by poverty and inequality. So, how can we fight AMR? Let us look at the 5 key takeaways for pharmacists. First, prescriptions are mandatory. Never give out antibiotics without a prescription. This is perhaps the single most important thing that pharmacists can do. Second, support AMR awareness. Tell your customers about AMR and educate them about the proper use of antibiotics. Third, provide basic knowledge about infection management to your customers. For example, make them aware that antibiotics are not effective against viral infections. Caution customers not to self-medicate and to go to doctors when necessary. You can also provide basic instructions about other remedies that do not require drugs. Fourth, ensure that pharmacy staff are properly licensed or at the very least are well aware and able to implement AMR guidelines and recommendations. And lastly, remember that as a pharmacist, you are a steward of the health of your community. Although not selling antibiotics may lose some revenue in the short run, fighting AMR supports patient health, which creates loyal customers and is ultimately good for business. Separately, teaching patients to avoid antibiotics can in turn give pharmacists opportunities to sell other products such as steam inhalers, headache and sinus medicine, hand wash, etc. to help customers manage their sickness. Resist the resistance.